Activity 1, researching. Measure the lengths of the arrows shown at the right. What is the relationship between these lengths? How does this relate to our research on perspective? The relationship between these arrows is that the farther the object, the smaller it looks. This relates to our research because, and I quote, smaller as their distance from the observer increases.
Trace the 4 arrows at the right, moving the paper to the left after tracing the longest arrow so that it is further away from the others than it is now. What do you notice? The first arrow drawn looks bigger than the same arrow I traced. Make a simple drawing of 3 or more similar objects whose lengths can be represented by an arithmetic sequence. Write the corresponding arithmetic sequence in a recursive or explicit formula for that sequence.
We drew 3 pencils. The first pencil was 4 centimeters, the second pencil was 3 centimeters, and the last pencil was 2 centimeters. Our formula was n-1.
Activity 2, designing. I drew 3 hearts. The hearts had a geometric sequence. The dimensions for each heart, the first one was 4.5 by 5, the second one was 5.5 by 6, the third one was 6.5 by 7, and the formula is n plus half.
Activity 3, analyzing. I drew a tree and a house. I cropped the house out. The tree had a width of 17 centimeters and a height of 18 centimeters. If I were to widen the tree where the house used to be, it'd be 21 centimeters.
Any of the 5 senses may observe geometric and arithmetic patterns. Abstract patterns in science, math, and/or language may be observed by analysis. Direct observations are visual patterns. They are widespread in nature and art. Visual patterns in nature are usually chaotic and are never repeated. They often have fractals. Natural patterns have spirals, meanders, waves, foams, tillings, cracks, and some are even made by symmetry of rotation and reflection. But all in all patterns have a math structure.
Action. This project was great! It's not funny. Just do it. I mean, I don't know what to say.
Action.
Chicken!